Hello, this is Paul from Foresight Tech. In this lecture, I'm going to introduce a very important tool in Calc 2 to evaluate the integrals. The name is called the Substitution Rules. Okay, and I was going to define going to show the theorem for Substitution Rule, and the most important, I was going to show a lot of I think it's 4 examples, and I hope you build the experience how to use the substitution rule to calculation. Here is the substitution rule. It's for indefinite integral. Okay, so it's for indefinite integral. So here, if we say u equals gx is a differentiable function, number 1, remember. So it means we can find derivative, and then whose range is an interval I. Most important, f is continuous on the interval I. Then, so we look at this. The beginning is a composite function, right? F composite g. Okay, this composite function times the derivative of these complicated integral functions. How to find the antiderivative or indefinite integral? So see, look at it. It's very simple. To the right side, after we do substitution, and this is the substitution, and this is the substitution. Okay. So later I will prove why this is correct. So first, let's look at the big idea. Okay, the big idea here I put a remark. So the big idea for substitution rule is going to substitute. After the substitution, we're going to get a symbol. Okay, get a much symbol for the integral function. Why we need this rule? We said the important rule, right? We already have fundamental, the second part of fundamental theorem, but that the theorem does not mean everything for us. A lot of integration we cannot directly find the antiderivative. We need a tool. This is one of the most important, and in the future we have one more. Okay. I will give you simple proof. So here, what we need to do, we go from the right side. All we need to do is this one take a derivative if it goes to the integral function, right? Okay. First, I do this. So that this is the antiderivative of lowercase f. We call the capital F, and this is a little easy. Okay, if we say capital F is the antiderivative of lowercase f. Okay, and then we will have all we need. So we look at the right side. So now the right should be equals to this. See, this is the right. And that goes to antiderivative is this, right, at a u. But remember, u is a function of g, so this we put together is exactly the right side is a composite function. What is the composite? Is alpha composed with g, right? Okay, and this is the right side, and then we want to prove the right equals the left. Means this take a derivative goes to the integral function. I will going to take a derivative to the right side. So here is the derivative. Okay, this is a bigger composite function. I take a derivative. See, if this take a derivative exactly goes to these complicated functions. And everyone know this is the chain rule, right? So we have a chain rule here. Okay, we have a chain rule. Okay, to find the derivative of the composite, which means the outer function take a derivative at gx times gx take a derivative. The derivative of the outer function times the derivative of the inner function, and then one more. So what is derivative of the capital? So here is a lowercase f, right? So that's f. Okay. Then what is g? Is still gx. Take a derivative. So we look at this. Is this the integral? Definitely. The right side is the integral functions. So it means we prove the right side take a derivative goes to the integral, means the right side is the antiderivative. So this is the antiderivative. Okay, this is the proof. And now I will going to show you 4 examples. Okay, we gradually to develop your experience. Okay, how to set up the substitution is the most important. The first, we just say the big idea of substitution is going to get simplified of the simplification of the integral function, right? So now we need to get this simple. This complicated is not a basic function. It's a composite function. Okay, so what is the inner part or the complicated part is here. I think everyone knows, right? How to do substitution for this. This is easy because we look at 5 plus 4x. Okay, so this part is the complex part, complicated part. So we need to substitute this. Use what? If we substitute this, use u. Okay, I simply say I use u to substitute this. U equals 5 plus 4x. If I do substitution, if I substitute in this way, and then easy, right? So this goes to u raised to the 7th power. Okay, and then how about the dx? Okay, the second is going to dx. Dx no longer dx, should be goes to kind of du. So we look at it, dx is linked to du. Okay, so how to link? So I will going to take a du here. Now I just put it here. Okay, and now du equals what? Everyone know du equals the derivative of u. Du is this. Do you remember the formula? Is u take a derivative to x, and then times dx, did the formula. Okay, and then I plug here. U take a derivative to x is 4, so we have 4 times dx. What does this mean? This means du equals 4 times dx, but we need the dx, so I'm going to solve. Okay, from here we solve for what? We solve for dx. So what is dx? So dx, this one should be equals 1/4 times du. Okay, so everyone, if we plug this into the integral function, the integral function will be changed, and the dx also will be changed into this way. Okay, I put this and that 2 together. This is the one we need for dx. This is the one we need for integral function. Okay, now what do we have? I directly plug there. Okay, so this one easy. I directly plug in there. So the integral, this is u, right? So it's u raised to the 7th power. What is dx? Dx is times 1/4 and du. Okay, so the first step is just a substitute. The second step, everyone know this is a constant number can factor out, right? So the constant multiply rule. Okay, so I put here is 1/4 constant number, and then integration to integral of this. This step is just simplify. Okay, and this is just to simplify. And the first step is the most important, substitute. Okay, do substitute. Now this is a single function, you know, right? So easy. So look at it. This is much easier than the older one, and this is a power function. We have the antiderivative for the power function. Okay, now easy, right? I just use the antiderivative of power functions. Okay, so now we're going to get what is the antiderivatives. So the antiderivative is this, right? Remember this? The power is 1 and then divided by a. Okay, this is the antiderivative of u raised to the 7th power. So one more, don't miss, we have to plus what? Constant number. This means all the antiderivative. This means one antiderivative plus c is all the antiderivative. Okay, and then can we stop it here? Okay, of course we not stop it here. 4 times 8 we can simplify, right? we say this is this 1 over 32 times u raised to the 8th power plus c. Don't stop at here. Be sure. Don't stop at here. Please do not stop at here. Why? Do not stop. Why? Because we look at the original question. Original question, the variable is x. Means this is the entire derivative of that. It should be a function about x. But now what do you get? You get a function about the u. What do you need to do? What is u? U is there. U is a function of x. You need to do back substitution. Okay, so you need to do what? You need to do this back substitute. Okay, substitute to x. Okay, that's all we need. And then let's look at this. So we back substitute the u equals 5. We're going to 5 plus 4 x raised to the 8th power. Okay, and then c. Okay, this is a back substitute. Now you get this should be the final. And then you can go into verify. Okay, and this take a derivative is goes to this integral function. You can go into verify by yourself. Okay, easy verification. This is the first, and we move to the second. Look at this one. Now, I think look at a little bit the difference, right? And this time a little bit more complicated, but it's okay. So which part is the trouble one or the complex the one, complicated the one? Which means 1 minus x squared or square root of that. If you take a square root of that, it will be complicated even more. If you take a 1 minus x squared, if we substitute this, it's good enough. Why? So you can think about this. But remember, when you take this, what is dx? Dx should be linked to du, right? So let's look at it. First, if we substitute this, that means you do substitution. If I say u equals 1 minus x squared, so square root of u, that is already easier, square root of u. How about this x? Do we need to exactly solve x from here? No, too complicated. Why? Because if we link this x and the dx together, so can we going to see what is du? The same, what is du? Okay, so we can look at the du. I skip one step. Is this take a derivative is negative 2x and then dx. Okay, look at the du and the dx. Keep in mind, you can solve for dx and then plug in. However, don't just solve for dx. You can solve for this. Okay, this time not just solve for x. Not just solve for x. Okay, for dx, but solve for this. But for x times dx. Okay, solve x times dx. This is important. Why? Because this is x times dx. You can switch the order, right? X times dx goes to kind of du. Okay, so if we're going to solve this, what do we get? See, it's easy to get. Do we get it? So we get x times dx equals negative 1/2 times du. Okay, and then now that's all we need. This is the substitution. Okay, so this goes to square root of u. And then the second part, x times dx. X times dx. Okay, it's going to kind of du. And these two plug into, so we will have, of course, the first step, this is one more step, okay, so look at it. And the first step, you need to change the position, okay, change the order of this. We call the rearrange, see? So we can do this. 1 minus x squared times x times dx. If you do this, and we call the rearrange. Just the range, okay, just just a simple rearrange. Sorry, it's a rearrange. Okay, I think is this right. Okay, just rearrange. Okay, rearrange the order in this way, and this is a kind of simple function. D times x times dx is there. Okay, and then plug in, and to substitution we have this integration square root of u, and what this is there. Okay, so times to put the parenthesis -1/2 times du. Okay, and this is exactly substitution, right? Okay, substitute. Okay, and then now it's easy function. There's a constant number we can take out. Okay, so I take the constant number out, and then goes to this one. Square root of u is better to raise to the power of 1/2. It's the same, right? And then du. Look at this function. This integral function is still the power function, right? Still power. So it means that we know still power. Okay. This time is 1/2 is 1/2. What is the antiderivative of this? I will going to put it here. Should be this. The power is 1 plus 1 should go to 3/2, right? 3 divided by 3/2, which means times 2/3. Okay, so we're going to do this. 3/2. See, and this is but this is not all the antiderivative. This is what? This is one antiderivative. We need to do something plus c. Okay, and then we're going to simplify. We're going to simplify. This time this is going to what? -1/3 u 3/2's power and plus c. I said don't stop at here, right? We need to do what? Back substitute. We need to do what? Back substitute. Okay, this step is important. Don't stop. Okay, back substitute for u this time is -1/3. U is there. Okay, so we're going to write 1 minus x squared, and then raise to the power of 3/2, and then plus c. Okay, this is the end of these questions. We already goes to the variable x, right? Good, and the same. See, look at this is something new, right? And compared to the first example, this is something new. You have to rearrange the order of the integral function. Okay, if you change the order, this you can directly resolve. Okay, directly resolve these two. This is composite. This part. And then look at one more, two more examples. And this one evaluated, I think is the same. Which part we need to substitute? And you probably will think substitute this. However, if you substitute the x squared, you will get trouble for x the third power. Okay, so this is complicated. The complicated part is not here. See, the complicated part is the power. Okay, so we can do substitute that. If we substitute the u equals x to the third power, the same, you're going to think what is du. Okay, du is take a derivative 3x squared, and the dx, where you get it. See, we still can change the order, right? If we change the order, we can solve. See, we can solve what? We can solve x squared times dx. Okay, if we solve this, what do we get? We get x squared times dx. X squared times dx. If we rearrange the order, okay, this goes to what? 1/3 times du. Okay, good. So see, and this substituted the first part we need for substitution, and this part is for dx part, right? The second part we have, and then I'm going to put here. Okay, so I just put here. Do substitution. No, not a substitution. And change the order first. So I will going to change the order So this times x square dx. Okay, this is a this is a rearrange, right? Rearrange, and then we can substitute that this part is substituted by this. The second part is substituted by this, and then what do we have? We have this. We have e raised to the u's power u, and the times this is 1/3 du, right? Okay, and then 1/3 take out. We're going to 1/3 take out, and then integration eu du. I think you know this is a special exponential function, right? Okay, so you can directly use the formula to find what is the nth derivative. So the nth derivative is itself. Okay. However, we don't miss this is plus c. Okay, and the last step, you know, is just to what? Back substitute. Don't miss this. Okay, back substitute. Back substitute. We will get this is 1/3. What is u? X raised to the third power, and then plus c. This is the end for these questions. We have the last question. Be patient. So we look at this. So how to do substituting? Which part is the complicated? It's not that. Okay, it's a sine add cosine. Okay, this cosine is the inner one. This is the trouble one. We need to make a substitution for this. Okay, so what we need to do is to substitute u equals cosine x, and then the same. Okay, what is du? We're going to du is a negative sine x times dx. See, if we switch the order, we can put the sine x times dx together. Sine x times dx. So we can solve, right? So we can solve this. Okay. After we solve this, is easy to get what? So sine x dx equals negative du. See, and then we have two parts. The first is substitution u. The second is for dx. This is the second part, dx or du. Okay, and I'm just going to finish these questions now. I put it here. So the first step is switch the order. I put this sine cosine x times sine x dx. Okay, and this part is a rearrange. This is a rearrange. See, all these questions we have to change the order. After we change the order, this is simple, and this is the second part also simple. And then I just put there. So this goes to what? Integration sine at u, right? Sine at u. Okay, and then what is negative? I put a parenthesis, negative du, which is negative 1 times du. Okay, and then we can factor the negative out. So negative this sine u du. This is a simple function, right? We have the nth derivative, which is negative cosine. Okay, so I put here is negative cosine u, because negative cosine u take a derivative goes to sine u, and then what? Then plus c, right? If we're going to see, we change. So negative goes to positive, which means cosine u plus c. But don't stop at here, right? The last, what? Back substitute. Don't miss this. Okay, don't miss this. And then substitute the u. What is u? The cosine x. Okay, so we get a very strange function, cosine add cosine. Okay, see, but it is still okay. Cosine add cosine is a composite function. Thank you. That's all.